Studying has always been a test of memory, but increasingly it is becoming a test of navigation. Not navigation through textbooks, navigation through information systems. In 2026, students are not simply reading and summarizing. They are interacting with AI systems that reshape how knowledge is organized, retrieved, and practiced. The shift is subtle. It does not replace studying, it restructures it. Today we will examine how AI tools are quietly changing the mechanics of learning, and how students can use them with intention. First, it helps to understand what has changed. For years, digital learning meant search engines, PDFs, and recorded lectures. Students searched for answers, copied notes, highlighted text. The tools were passive. Now AI systems are interactive. Large language models can explain a concept in multiple ways. Adaptive study platforms can identify weak spots in comprehension. Note-taking systems can reorganize information dynamically. The difference is not intelligence alone, it is responsiveness. AI systems now respond to how you think, and that alters the structure of studying itself. Let us begin with explanation tools. Conversational AI systems such as ChatGPT or Claude are often treated as answer machines, but their real value is iterative clarification, instead of asking, "What is photosynthesis?" A more effective approach is layered inquiry. Explain it in simple terms, now relate it to cellular respiration. Now test me with 3 conceptual questions. Now challenge my misunderstanding. What changes here is agency. The student becomes a director of explanation. The AI becomes a flexible tutor. The system is most powerful not when it replaces thinking, but when it pressures thinking. Second, there are AI-enhanced coding and technical study tools. Systems like GitHub Copilot assist with syntax and structure. For students learning programming, this reduces friction, but it introduces a risk. If the AI writes the solution too quickly, the learning process compresses. The better approach is constraint-based use. Ask the system to explain why a solution works. Request partial hints instead of full answers. Have it generate edge cases to test your logic. Used this way, the AI becomes a debugging partner, not a shortcut. Third, note organization has shifted. Tools such as Notion and Obsidian increasingly integrate AI features that summarize, connect, and restructure notes. In the past, students manually reorganized information. Now AI can cluster related ideas across weeks of lectures. This reveals patterns, connections between themes, recurring principles. Instead of static notes, students maintain living knowledge systems. The practical implication is important. Understanding improves when relationships are visible. AI makes relationships visible. Another emerging shift is in adaptive practice systems. Language learning platforms like Duolingo have incorporated AI to personalize difficulty. The system adjusts repetition intervals, identifies hesitation patterns, reintroduces weak vocabulary. This is not dramatic, but it is cumulative. Small adjustments in spacing and difficulty can significantly improve retention. The AI is not teaching the language, it is managing timing, and timing is often the hidden variable in effective study. There's also a quieter development in research workflows. AI tools can now summarize academic papers, extract key arguments, and compare methodologies. For students working with large reading lists, this reduces initial friction. But again, the system works best as a filter, not a replacement. A productive method is staged engagement. First, request a structural summary. Then identify the sections most relevant to your topic. Then read those sections in full. AI narrows the field of attention. It should not eliminate deep reading. What unites these tools is not automation. It is feedback loops. Traditional studying often lacked immediate feedback. Students would study for days, then discover misunderstandings during an exam. AI compresses that loop. You can test comprehension instantly, generate variations of a question, simulate exam scenarios, ask the system to argue against your thesis. The effect is subtle but powerful. Learning becomes iterative, less linear, more conversational. However, misconceptions are common. One assumption is that AI makes studying easier. In reality, it makes it more interactive. The cognitive load shifts. Instead of searching for information, students must evaluate responses, detect inaccuracies, formulate better prompts. This requires meta-learning, learning how to learn with systems. The tool does not remove effort. It redistributes effort. Another misconception is that AI tools reduce originality. When used passively, this can happen. But when used strategically, AI increases divergence. You can request alternative interpretations of a theory, compare historical perspectives, generate counterarguments. Originality emerges from synthesis. AI expands the raw material available for synthesis. Why does this matter for everyday students? Because the structure of exams and assignments is evolving slowly. Educators are aware of AI assistance. Assessment is shifting toward application and reasoning. Memorization still matters, but interpretation matters more. Students who use AI only to produce answers may struggle when required to defend them. Students who use AI to stress test understanding gain resilience. The difference lies in intention. There's also a broader pattern. AI systems increasingly track interaction behavior, time spent on question, types of mistakes, areas of hesitation. This data shapes personalization. For students, this means study environments are becoming adaptive ecosystems, not fixed curricula. The implication is long-term. Learning paths may become more modular, more responsive, more individualized, but this requires responsible engagement. Blind reliance reduces growth. Conscious collaboration increases it. At a system level, AI in education reflects a larger trend. Tools are moving from static repositories of knowledge to dynamic partners in reasoning. This does not eliminate textbooks. It augments them. It does not remove teachers. It supplements them. The quiet transformation lies in mediation. AI mediates between the student and information, and mediation changes experience. For students in 2026, studying smarter is less about finding the perfect tool. It is about designing a workflow. A possible structure is simple. Begin with concept exploration using conversational AI. Move to structured note synthesis. Use adaptive quizzes to test retention. Return to AI for challenge questions and counterarguments. End with self-explanation without assistance. This cycle preserves effort while improving feedback. Notice what is absent. There is no dramatic breakthrough, no singular system that replaces learning. Instead, there is integration. Small adjustments in how information is surfaced, how weaknesses are detected, how repetition is timed. These adjustments compound. Over weeks and months, they alter outcomes. The deeper shift is philosophical. Knowledge is no longer scarce. Interpretation is. Students who cultivate discernment, who question outputs, refine prompts, and reflect independently will benefit most from AI tools. The technology amplifies direction. It does not supply it. In the end, studying in 2026 is not easier. It is more interactive, more responsive, more iterative. AI tools are not substitutes for discipline. They are instruments for structured curiosity. Used thoughtfully, they reduce friction. Used carelessly, they reduce depth. The difference lies not in the model, but in the mindset. Learning has always evolved with tools. From printed books to search engines to intelligent systems, each transition reshaped habits. This one is quieter, less visible, but structurally significant. And for students willing to engage deliberately, it offers something rare, not shortcuts, but leverage. This is Neural Pulse Lab, quiet patterns, careful analysis, and the systems shaping how we think.